Hi dear students, once again welcome back to our channel. In this video I am giving a quick revision on polynomials, that is chapter 2. Okay, so one by one we can revise what all topics we discussed so far. Okay, and the first point itself is degree of the polynomial. Okay, and what is exactly polynomial? Polynomial means it will contain only one single variable, that is the polynomial we discussed in this 10th standard. So let it be p of x. A polynomial can express in this form p of x, g of x, r of f of x. Okay, these are the representation of polynomial. This x represents or shows that is a variable in that polynomial. And for example, I am giving you 4x cube plus 2x minus x plus 2. This is a polynomial in x. In x means this is the variable. X is the variable. Okay, and what is the degree of the polynomial, children? Degree of the polynomial is the highest power of the variable in it. Highest power of the variable. Here the variable x, that is its power is 3. Here is 2x square. Here the variable, the x in its power is 1. And among this variable, that is that first term having the highest power. Okay, so 3 is the degree of the polynomial. That is very important. Okay, highest power of the variable. See, sometimes you may getting the variable that a polynomial of the form 0x raised to 4 plus 3x cube minus 2x square plus 2. See, here you can see that the highest power of the variable is here 4. But it's in that term having the highest power 4, its coefficient is 0. That means we can't consider this term. Okay, so while you are writing the degree of the polynomial, make sure that that term has the coefficient must be a non-zero number. If 0 comes, we can consider that term for writing the degree. Understood? Okay. See, and after that we have different types of polynomial. That means degree 1, degree 2, degree 3 and degree 4 sometimes. But in this year we are concentrating only for quadratic polynomial. Okay. So a polynomial of degree 1 is called linear polynomial. Here it is quadratic, I already told, quadratic polynomial, cubic polynomial. This fourth degree we are not that much considering in this year, and anyhow that is what we call biquadratic polynomial. That means the degree depends on, we can classify the polynomial, and number of terms depends on the number of terms. We have monomial, binomial, trinomial, polynomial, more than 2 terms polynomial. The same way, based on its degree, we have these are the different types of the polynomial. Polynomial of degree 1, that is 2x plus 3. See children, here the variable x is power is 1. Okay, here you can see that 2x square plus 7x minus 2. Power is 2. So this is a quadratic cubic polynomial. Already we have biquadratic. If we have here 3x raised to 4, this will become a fourth degree polynomial is biquadratic polynomial. Okay, see, and after this degree, so that you can expect one question from this degree of the polynomial sometimes. Okay. And what is the degree of the constant polynomial, constant term? See children, see if this in this polynomial, see if I am asking you what is the degree of the polynomial, constant polynomial, that is 2. That constant polynomial you can express also p of x. The only condition you can express this as 2 into x raised to 0. If p of t, what is the condition? 2 into t raised to 0, because a raised to 0 by loss of exponent, a raised to 0 is 1. So if you multiply 2 with 1, okay, that is you will be getting the same polynomial, constant polynomial 2. Okay, that means you can express even a constant in terms of its variable by making its power 0, because a raised to 0 is 1, x raised to 0 is also 1. So 2 into 1 is 2 itself. So the degree of the constant polynomial is always 0. But the degree of the 0 polynomial, the number 0, its degree is not defined. Degree of 0 polynomial, the number 0, okay, its degree is not defined. Okay, so after this degree, we have that how to represent this polynomial graphically. Okay, that means looking the graph, you can decide, okay, that which type of polynomial is. Okay, see, if we have a linear polynomial, its graph, always will be a straight line. Okay, it will be like this and it will intersect at this point. This is for the linear polynomial. Okay, for a quadratic polynomial, its graph is always like a parabola. This is a straight line. Okay, in case of a quadratic polynomial, its graph is a parabola. So the graphical representation of a quadratic polynomial is always a parabola. Okay, and sometimes it will open upwards and sometimes it will open downwards, and when a greater than 0 it will open upwards, and when a is less than 0, negative number, the coefficient of x square, then that parabola open downwards. Okay, and the next is for cubic polynomial. Cubic polynomial means its degree is 3. So it will the graph is always of this type. Okay, it will intersect like this. Okay, that x-axis and y-axis, the graph will look like this. Okay, and that next is the fourth degree polynomial, that is biquadratic polynomial, means it will intersect this in this manner. So next is the value of the polynomial. See, value of the polynomial. So for that I am giving you a polynomial p of x is equal to x square plus 5x plus 6. Okay, we should get the value of this polynomial. That means what is the variable here? X. Give that value. So the next is the value of a polynomial. Okay, value of a polynomial means, suppose I am giving you a polynomial that is p of x is equal to x square plus 5x plus 6. We should get the value of the polynomial when x is equal to 1. Okay, that means in place of the variable we are substituting the given value. For x is equal to 1, what will be the value of this polynomial? Okay, that is substitute or replace x with the given number. Okay, that is p of 1 equal to, okay, that is 1 square plus 5 into 1 plus 6 is a constant term. Okay, so you will get that is 1 plus 5 plus 6, that is 12. 6 plus 6 is 12. That is p of 1 equal to 12. Okay, in some cases, okay, if we are getting, if p of 1 or p of x is equal to 0, which value you are getting this, which make this polynomial into 0. Okay, if p of x is equal to 0, that value is said to be 0 of the polynomial. Understood? Or in order to get the 0 of the polynomial, this is the condition, children, equate that given polynomial into 0. And you can easily find out their zeros. That point is clear, that 0 of the polynomial is nothing but the value which makes that polynomial into 0. That is p of x equal to 0. That value of x is what we call 0 of the polynomial. 0 of the polynomial. Okay, if I am substituting in place of this 1, if I am making here minus 2, let us see what is going to happen. Minus 2. Okay, minus 2, that is minus 2 whole square plus 5 into minus 2, okay, plus 6. Here minus 2 whole square is 4, minus 10, okay, and here plus 6. That is 4 and 6 is 10 and minus 10, that is equal to 0. That is, here we have seen that p of minus 2 equal to 0. That means minus 2 is a 0 of this polynomial, quadratic polynomial. Okay, so idea is clear, children. That means the value which makes that given polynomial 0 is what we call 0 of the polynomial. Okay, so based on that 0 of the polynomial, if you have the graph, you can count the number of zeros. Okay, number of zeros. Being it is linear straight line graph, okay, and you can see that you see how many places that graph is intersecting the x-axis. Okay, here this graph is intersecting at one point, so a linear polynomial has maximum 1 0. Okay, so 1 0. One number of 0 is 1. Here in quadratic polynomial, okay, it is intersecting this x-axis at two points. So a quadratic polynomial has 2 zeros. Okay, and the place where that graph intersecting, how many places that graph intersecting that x-axis, okay, that will give you the zero of the polynomial. Okay, and here number of zeros, in order to get the number of zeros, here for cubic 1, 2, 3, and so a cubic polynomial has 3 zeros, maximum 3 zeros. Okay, here a biquadratic has 4 zeros. Okay, the number of places that graph is intersecting the x-axis, and in order to write exactly that zero, write down the coordinates of this point and its x-coordinate will give you the zero. That points are clear, children? In order to get the number of zeros, see that graph, how many places that graph is intersecting that x-axis, that will give you the number of zeros. In order to get the exact zero, the value of zero, okay, which make that equation zero, okay, for that you write down the coordinates of that point, okay, and its x coordinate will give you the value, that zero of the polynomial. Okay, so a quadratic polynomial, 2 zeros, you can easily write down by writing the x coordinates of these points will give you the zeros of the polynomial. Understood? Our next point is based on remainder theorem and the factor theorem. This also plays a very important role in polynomials. Okay, see, what is remainder theorem? If we are dividing a polynomial p of x with the factor x plus a, okay, the remainder will be always minus a. P of minus a will be the remainder. That means if you are dividing a polynomial, that is ax square plus bx plus c with the x plus a, okay, that remainder is always equal to p of minus a. Okay, without dividing you can find out that it's a remainder. That is, if x plus a you are dividing, okay, that p of minus a equal to the remainder. If x minus a, if you are dividing that polynomial with the x minus a equal to 0, so x is equal to a, this is equal to the remainder of that p of x. That is very clear, children? Okay, and from this we can easily explain what is the factor theorem. Okay, and for which value, that means if that remainder is 0, if you divide a polynomial, that means we have seen the previous case that polynomial p of x is equal to x square plus 5x plus 6, and we have seen that p of minus 2 equal to 0. That means if you substitute minus 2 in this polynomial, that minus 2 makes this p of x 0. That means here the remainder is 0 and this minus 2 is called, that is the value which makes that polynomial 0. Okay, if it is minus 2, then you can say that x plus 2 is a factor of that p of x. Understood, children? Okay, that means that the value which makes that p of x 0, okay, that is x minus 2. So if that variable is x, so x plus 2 will be the factor. If x, that is p of 2 equal to 0, if so, p of 2 makes, if you substitute x as 2 and if you are getting that a p of x equal to 0, that means x minus 2 is a factor. That is a relation between the remainder theorem and the factor theorem. Okay, the value which makes that equation 0, and you can express that in terms of factor. If p of minus 2 is 0, that means x plus 2 is a factor. If p of 2 is equal to 0, then x minus 2 is a factor. Okay, and other words, in order to get the remainder, okay, if you are dividing a polynomial with x plus 3, then x minus x equal to minus 3, that is, that value will give you, if you replace that x with minus 3, you will get the remainder. In that case, if remainder is 0, you can say that x plus 3 is a factor. It is clear, children? If you are dividing a polynomial with x plus 3, the remainder equal to p of minus 3. If p of minus 3 equal to 0, you can say that x plus 3 is a factor. This is all about the remainder theorem and a factor theorem. So our next point is, see, I already told we are concentrating the quadratic polynomial in this year. Okay, see, for quadratic polynomial, that is ax square plus bx plus c. This is a quadratic polynomial. P of x is equal to ax square plus, this is general form. Okay, in place of you can consider any of the quadratic polynomial, that doesn't matter. Okay, see, in this quadratic polynomial, its degree is 2. That means it has 2 zeros. Okay, for 2 values you can make this p of x into 0. That is the meaning of 2 zeros. Or the graph is a parabola and it intersects the x-axis at 2 points, and x coordinate will give you the zeros of the polynomial, quadratic polynomial. These are the things we have discussed so far. Okay, see, let these zeros can be represented by alpha and beta. Alpha and beta are the zeros of the polynomial, that is quadratic polynomial, only 2 zeros. Okay, and you can relate this with the coefficients of the polynomial. That means here these alpha and beta are the zeros. That is the relationship between the zeros and the coefficients. Coefficients are nothing but the coefficient of x square in the given polynomial, coefficient of x is b, and the constant term. These are what is we call coefficients of the quadratic polynomial. Okay, and alpha and beta are the zeros of the polynomial. And whatever that alpha and beta, the sum of the zeros, that is alpha plus beta. See children, always 0 means alpha and beta, coefficient means a, b and c. See, you can relate this, equate this alpha plus beta equal to minus of b by a. Minus of b by a. And alpha beta, product of zeros, alpha and beta are the zeros, so sum is alpha plus beta, product is alpha into beta, and that is equal to c by a. See, in here the first one, that is sum of the zero, minus b is negative of the coefficient of x. That means if I am giving a polynomial, quadratic polynomial, x square plus 5x plus 6. Okay, we have seen that p of minus 2, that is minus 2, p of minus 2, and p of minus 3 also you can see that this quadratic polynomial can make it a 0. That means here alpha and beta. Here alpha equal to minus 2, beta equal to minus 3. So alpha plus beta, minus 2 plus minus 3 minus 5. This will be equal to sum of the zero is equal to, what is it, in terms of their coefficients. Okay, that means minus of b by a. Okay, that means coefficients you can compare with the general equation. X square, that is coefficient is here, a is equal to 1. A equal to 1, B is equal to 5, and C is equal to 6. Okay, and you can see that minus B by A. So what will be minus B by A? Minus 5 by A is 1, that is minus 5. We already have seen that this is equal to minus 5. That is always sum of the zero is equal to minus b by a. This is a relationship between sum of the zeros and the coefficients of the quadratic polynomial. That is alpha plus beta is equal to minus b by a, and the product of 0, that is alpha into beta. What is alpha into beta? That is minus 2 into minus 3 is 6. This is alpha beta. And what is c by a? C by a. C equal to 6. And a equal to 1, 6 by 1 is 6 itself. Okay, so this is the relationship between. See children, how we can find out this minus 2 and minus 3? Okay, that means for that I already told, equate this given polynomial into 0. That means p of x equal to 0. That means x square plus 5x plus 6 equal to 0. By splitting the middle term method, you can easily get it. Okay, here you can see children, x plus 2 and x plus 3 equal to 0. Okay, and each factor can be equated to 0. X plus 2 equal to 0. That means x equal to minus 2. If we equate x plus 3 equal to 0, x is equal to minus 3. Let this x is equal to alpha and second 0 equal to beta. That is how we got x is equal to alpha and beta as minus 2 and minus 3. Okay, so by splitting the middle term method, you can get to the zeros of the polynomial, and you can apply the identities a square minus b square, a plus b into a minus b. Okay, sometimes that is x plus a whole square, that is a plus b whole square, or x plus a into x plus b, that is actually the splitting the middle term method. Okay, these are the identities you can apply in order to get the zeros of the polynomial, that is quadratic polynomial, by splitting the middle term method is we are usually using. Okay, and here this is a relationship between the sum of the zeros and product of zeros. And one more very important point, that is, if you know the sum of the zeros and or the zeros, simply zeros alpha and beta, or the sum of the zeros and the product of zeros, you can easily form a quadratic polynomial. I will by taking the same example, I can show that how can we form a quadratic polynomial if you are getting the zeros of the polynomial. See, if I am giving you alpha equal to minus 2 and beta equal to minus 3, what is the corresponding quadratic polynomial having the zeros minus 2 and minus 3? Okay, we don't know what is the polynomial, but we can easily reach into this polynomial only when we know it's the zeros, alpha and beta. Okay, this is that form, that is p of x is equal to any polynomial, quadratic polynomial, x square, if it is x, x square, if it is y, y square, that's all, minus alpha plus beta into x, okay, plus alpha beta, plus alpha beta. This is the very important equation to form a quadratic polynomial, provided you are giving alpha and beta, two zeros. Okay, that is x square minus of alpha plus beta into x plus alpha beta. We are using this equation to get that polynomial. Let us see, we reach into that equation, that is p of x is equal to x square minus, what is alpha plus beta? Alpha plus beta, we have seen that minus b by a minus 5. Okay, alpha plus beta, here see children, minus 5. So this sign minus is already there, and alpha plus beta equal to, see children, this is minus of b by a, that is alpha plus beta, that we already have seen. Okay, so here this minus and this minus also there, that is minus 5 into x plus alpha beta. What is alpha beta? Alpha beta is 6. I already rubbed that portion. Okay, so this is equal to x square minus of minus plus 5x plus 6. This is the polynomial we already have taken. See children, x square minus 5x plus 6. So if you know the zeros of the polynomial, okay, you can easily form its corresponding quadratic polynomial. Okay, that is, this is the very important equation, x square minus of alpha plus beta into x plus alpha beta. So apart from the points which we have already discussed, definitely we are expecting some different question from this lesson, polynomial. And for that children, these are the areas to be noted. That is, if we have a polynomial, that is p of x is equal to x square plus 5x plus 6. For easy, I am taking that polynomial always, okay. And see, if sometimes if it is, find the value of 1 by alpha plus 1 by beta. How to find out 1 by alpha plus 1 by, we don't have any identity in terms of 1 by alpha plus 1 by beta. If it is alpha plus beta whole square, you can use a plus b whole square, that is algebraic identity, okay. But here 1 by alpha and 1 by beta, okay. And for that children, you have to cross multiply, that is beta plus alpha or alpha plus beta by alpha beta. See, you can easily get the answer if you can convert a quadratic polynomial of this form, alpha plus beta and alpha beta, or alpha or its powers, alpha plus beta whole square or alpha beta whole square. If it comes, if you know alpha plus beta, you can substitute and you can square, and so that you can reach it to the answer. Okay, other than this, if this is of this form, directly we won't get to the answer. You have to do the cross multiplication. You can make that in the form alpha plus beta and a alpha beta. Okay, see children, if it is of alpha square plus beta square, how will you get to this one? Do you think this alpha square plus beta square is equal to alpha plus beta whole square? Not equal to. Okay, alpha square plus beta square and alpha plus beta whole square, that both are different. Okay, so in order to get its value, Okay, for that we have an identity. What is that? A plus b whole square, that is alpha plus beta whole square we know. What is that? That is alpha square plus beta square plus 2 alpha beta, 2 times alpha beta. From this, children, you can get alpha square plus beta square by taking this 2 alpha beta to LHS, that is alpha plus beta whole square minus 2 alpha beta equal to alpha square plus beta square. So we need alpha square plus beta square, and we got this alpha square plus beta square in this form, alpha plus beta and alpha beta. Alpha plus beta you can get from this minus b by a by comparing the coefficients, minus b by a and alpha beta equal to c by a. Okay, so that you can easily get alpha square plus beta square. So this is very important identity. This form also you should be noted. Alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha beta. This in the same way, see children, alpha cube, in the same way alpha square minus beta square. Okay, that can be also asked. So alpha cube plus beta cube. And for that you can see this term in a plus b whole cube. Okay, for that you can expand it by taking this as alpha plus beta whole cube equal to alpha cube plus 3 alpha beta into alpha plus beta. Okay, and next is plus beta cube. So if you are keeping alpha cube plus beta cube alone, you can take alpha plus beta whole cube. Okay, and this term minus 3 alpha beta into alpha plus beta. This is equal to alpha cube plus beta cube. Alone in the RHS we have taken this, so hence it becomes minus 3 alpha beta into alpha plus beta. So children, in order to get alpha cube plus beta cube, now see in the LHS, see if you know sum of the 0, that is alpha plus beta, take its cube, minus 3 into product of alpha beta, zeros, and again alpha plus beta, that is the sum of the zeros. Okay, definitely children you can expect a question by using this idea. Okay. So children, this is all about the polynomial. I have given a very quick revision upon this lesson. Okay, so do practice maximum problems. You have only 2 more days for the examination. Okay, so without wasting much time, you practice the problems which I already asked for the examination, like your model examination, and some question I already have given as revision questions, and the sample question paper we have completed. Okay, so get practice so that you can see that which area that questions are asking. Okay, so without wasting your time, so do practice all these problems. Okay, so thank you children, thank you for watching and supporting my channel. May God bless you all.